Hi, welcome to Building SaaS with Python and Django. My name is Matt Lehman, and on this stream we work on Django apps and do things related to the web. We're going to continue on Python training, I guess. We're doing some exercises with Python using a site called exercism.org. So we'll start with one of those as kind of a warm-up and to give you some exposure to Python, and then we'll do some Django stuff. I was thinking also we might do some Go work this evening. I've got some projects that I'm interested in honing some of my skills, so I figured we could all learn together. So that might be in the cards tonight, depending on how much time we have. But we'll start first with Exercism, and let's look at what exercise is next. So I've done some exercises in the past on the stream, and we need to take a look at what's next for us. So let's jump over here and check back on the syllabus and see what's left for us. So Exercism walks you through different ways to learn Python, different parts of it. Cool, John, 1080p, looking good. That's a good start. Welcome, by the way. And we'll continue down here and see where we're supposed to be, what exercise is slated for us to learn next. It seems to be about dictionaries, so let's jump into it. So there's enough of information about dictionaries. I personally have used Python for a long time, so I don't need to cover dictionaries myself. But as we will get into the exercise, I'm sure we'll be exposed to different features of them. So let's look at this. We got inventory management, and we can copy the exercise and get it going. And start over here, paste the exercise, and it should download our inventory management project. And I'm going to copy this pytest ini file. Something I found with these exercises is that the test suite that comes with them does not include the file, and it makes the test harder to read. So we'll do pytest.ini. Each exercise comes with a full test suite that we can work from. And so we'll do that, and we'll go into the exercise directory, which is inventory management. We'll try running pytest to show that we've got a bunch of failing tests to start. So they start with failures, and we work to fix them up and fix up the code that is given to us and follow along with the exercise instructions. So let's take a look at what is in store for us. It says, in this exercise, you will be managing an inventory system. The inventory should be organized by the item name and should keep track of the number of items available. You will have to handle adding items to an inventory. Each time an item appears in a given list, increase the item's quantity by 1 in the inventory. Then you will have to handle deleting items from the inventory. To finish, you will have to implement a function which returns all the key value pairs in an inventory as a list of tuples. Okay, so it seems straightforward enough. So let's start with the first item on here. We want to create an inventory based on a list. We implement create inventory, which is a function that takes an inventory from a list of items. It should return a dictionary containing each item name paired with their respective quantity. Okay, so the example here is showing that there can be multiple of items. So we've got 1, 2, 3 for coal, wood, and diamond. All right, that seems doable. I don't know off the top of my head the best way to put this together. There is like the obvious choice to me, but there might be like better methods that I'm not aware of. And I'm new to, like, I've got a new multi-monitor set up here, so if you see me looking around and not paying enough attention to y'all, I'm still adjusting, so hopefully you'll bear with that part. Okay, so let's start with doing something different. I don't have my virtual environment activated for this, so I want to have that because that will enable us to run pytest right from within my editor. So then we'll jump back into the inventory management project and open up the dix.py file, for dictionaries. And then now with my editor running, that should have done something, but it didn't seem to run black. Why not? 1 second. Black is there, so it should be running on save. All right, well, whatever. We can deal without that for now. I'm going to get rid of all these pass statements because we're going to be adding an implementation for each of them. And then, there we go. Now it's working. So let's start with create inventory. So we know that we need to create a dictionary that has, Mark, welcome. Thank you for subscribing. Thanks for joining in. I'm actually new to this part as well. I can actually see the stuff that would be flashing on the screen in the past that I wasn't able to see before. So we need to go through each of the items and add them to a dictionary is the short way to think about this. So let's do that. We want to loop over the items is the shortest thing I can do. And let's create a dictionary called inventory and have it be an empty dictionary. And then as we go through each item, we'll say, we can do this first. So if item is then in the inventory, then we can do inventory item equals, can we do, I guess we could do plus equals 1. So that should increment it if it's already there. But we can't just do an increment on something that is not there. If we were to try and say this, like, just do something like, let's comment that out and pretend like this. If we tried to do this, that wouldn't work because the plus equals here is really implying that you really want to write something more along the lines of this. And that's what the plus equals is doing. So in this case, whoops, inventory. And what would happen in this case is that the first time you try to access this, there's nothing there. There's no 0 to start from. And Python is not going to make one available for you. We could actually maybe refactor this so that to use a different type of data structure that will do that. But that's not how it goes by default. So it would give a key error. It would say, like, this doesn't exist in the dictionary, so there's no value to do. So instead, what we do is do a check. If it's in there, then we know we can increment it. Otherwise, we need to add it to the dictionary for the first time, which looks like this. So inventory item equal to 1. So that should solve that. And then we can return the whole inventory as the thing we're after. So I think that should solve the test. So looking for create inventory, there's one test here. And let's see if that test passed after we run this. I don't see it anymore, so then we have one pass. So I think we got it right. How else could we do this? We could do this with something called a default dictionary from the collections module. And let's see, if we bring up the Python docs and go to the library reference, which is a very trusty thing to look at, and look for the collections module. There's a bunch of stuff in collections. And collections has this default dict. This is a useful thing that will allow you to essentially set something when it doesn't have a key. So you could say instead of using inventory as a dict, you could do a default dict here, and then it would simplify this for loop considerably, because then you wouldn't have to have this check. You would just say plus equal to 1 all the time. So if it started out, well, let's just do it. Let's actually have the alternate implementation here. So we've got this, and we'll say from collections import default dict. And now we're going to have a different version of this, which will be inventory is equal to default dict. And you have to give it an argument of what is the default going to be when you don't have a key there. So it's going to be an integer in this case because we want to be adding. So we're going to do that. And it needs something that is callable, in which case int is a callable here. And now we can do something similar where we say for item in items, but in this time we can do this as in what seemed like a dumber way to do it, of saying item plus equal to 1. So what's going to happen is if there's no key there, the default dict will create a key and give it a default value for int, which should be 0. And then we should be able to return inventory, and that should give us the same result if I did that right. So let's see if I wrote the code correctly. And we still get a passing test. So this version is slightly shorter, and it takes advantage of this default behavior. So I'm going to keep that version. Why not? We did the work to make it shorter and sweeter. There's probably an even simpler way to do this with counting that I'm not thinking of. Some method on a dictionary itself that is not coming to mind, but that's whatever it is not jumping out to me. We'll review some solutions online and see if somebody has come up with something more creative, but this is not bad. It's only 4 lines of code. All right, let's move on to the next one. So our next thing is to say add items. So add items from a list to an existing dictionary. So here is essentially, this is our inventory that we had from step 1, and we want to add more to it. So it's kind of like this thing, but we're starting from a place that has a starting point. That didn't make much sense. I'm trying to think of like, can we reuse this? I've seen some people kind of like hack the solutions where they use keyword arguments and take advantage of that. And maybe we can here. So let's try that. Let's say inventory is equal to none. So if it's none, then we want to create a default dictionary. So if inventory is none, then we want to create this inventory with a default dictionary. So that test should still pass, that first test. All right, it still passes. Now, though, we can use this create inventory as the like function inside of our add items thing. So we can say return, where we call create inventory, which is probably misnamed for this context, so I'm sort of abusing it in that way. And then we pass it the items, and then we pass inventory as the second argument. I don't have to give it a keyword argument. In fact, I probably won't, because it can operate with a positional argument too. So this should make the add items tests work now. So what happens in this case? Like in this case, this will be inventory is not none, so it'll skip this step and use the existing inventory that's been passed in, which is the same one from right here on line 18. So if we go over to the tests, there is maybe all of these things. I don't know how many of them are going to pass after we do this. So let's try it. Got three tests passing now. So cool. I think that was right. Let's see. Let's go to what's next. We want to, and there might be some tests that we didn't maybe account for corner cases, so we may need to be modifying other stuff a little bit later. But let's do all of the steps first through the exercise, and then come back and see if we can get if there are corner cases that are covered here. So decrement items from the inventory. So now we want to take something that has an items. So it takes an inventory as one thing and the list of items as the second thing. And the function should remove one of the available count in the inventory for each time an item appears in the list. Okay, so then it says there's more information though. If the items count in the inventory, the items count in the inventory should not fall below 0. So that is like a guard condition. We shouldn't go negative. If the number of times an item appears on the list exceeds the count available, the quantity listed for that item should remain at 0, and additional requests for removing that should be ignored. Okay. So we can come over to here and we can come over to this decrement thing. So what do we need to do in this case? We need to, still iterating over the list of items and modifying it. So for item in items, these are, and we can give this, we'll call it item to remove, I guess, in this context. And then we can look in the inventory and see if it's there and decrement. But we also have to do that conditional check for 0. So if we only want to do it if it's greater than 0. So if item to remove is in the inventory, that dictionary key checks are when you do something in on a dictionary, it checks against the keys, which is what we want in this context. So if the item is in the inventory and that's that value, it has to be greater than 0. So inventory item to remove must be greater than 0. Then we can do the decrement. Otherwise, we have to leave it alone. So then we do inventory item to remove minus equal 1. And we have to return the updated inventory after we're done. Let's put it right here of return inventory. Okay, so that should do that one correctly. So let's run our tests and see what passes this time. Got 5 passing. So, all right, seems like we're doing okay. Let's look at number 4. So this says implement the remove item function that removes an item and its count entirely from an inventory. If the item is not found in the inventory, the function should just return. So we could do the way we can handle that is using the del keyword on dictionaries, which will take something out of a dictionary. So I think if you try to delete something that is not there, I believe you get a key error. So we don't necessarily want to do that. So we want to say if item in inventory as a guard. Some people might argue that you might want to do a try except here, but it's a very reasonable operation to try and remove something that's not there. And I want to reserve exceptions for exceptional cases. So I'm okay doing a check before in this scenario. So if it's in the inventory, then we want to delete del from the inventory. Oops, not inventory. We want to delete that, which I think should delete the key, and then we should be able to return the inventory as a full thing. Okay, so how'd that do? All right, they got rid of those. I'm thinking we maybe missed something on the add because there's a couple of add tests that maybe should have run that are not passing. We'll carry on. So return the item inventory content. This implements the list inventory function that takes an inventory and returns a list of item quantity tuples. The list should only include the available items with a quantity greater than 0. Oh, interesting. Okay, because otherwise this would be fairly easy to do. There's a Python function on dictionaries called items. So if we bring up Python here, and we have d of a 4, let's say, and let's actually put a second item in there. So b6. So there's 2 things in here, and you could do items, and this is going to return a dict items iterator thing, but you could also pass this to a list to get just a raw list of them. So that's exactly what they're talking about. It's a list of tuples in that format. So that would be like the easiest way to do that, but they make it a little harder by saying you must exclude the anything with 0. So we could probably cover that with a list comprehension. Yeah, let's try that. Let's do return. The key, let's see, the item and the count for item and count in inventory items if count is greater than 0. So that comprehension should do what we need to do. And let's run PyTest to prove it. Okay, great, it did. So we've got 2 tests that are failing that we need to go back and fix up. And then I think we'll be done with the exercise and we can check out some solution. I'm actually curious to see what kind of other answers we get with this process, because there's probably some creative stuff out there. So we've got 2 tests that we need to check on. The test add from empty dictionary. Why did that fail? Key error on iron. All right, so let's bring up a second file. And have them side by side. And so the test was failing was test add from empty, test add from empty. So this one failed. Okay, maybe my my default dictionary version is not working the way I would think. Key error. What am I missing? Am I missing a default value on the default dictionary? Default factory. So the default factory is that's the factory function that should be returning some kind of item. So why seems to be failing on that step. And add from empty dict. Add new item. Well, shoot. It's not what I anticipated. All right, let's bring up the REPL. I want to see what's going on here. Collections, import, default dict. And we'll say our default dict is a default dict with an int thing. And that's going to be foo plus equal 1. See, that worked. Oh, okay. I see where we broke. We violated. All right. So because I kind of cheated here and then we reused this function, I see how this is failing. So now this thing is passing in an inventory and it's getting in here. And so our code right here expects to be using a default dictionary, but it's only getting a regular dictionary when we call it from that add items function. So I think in this case we have to use, like, although the default dict thing was cool, I think if we want to continue to reuse this, we need to use a regular dictionary and bring back our check here. So if item is in the inventory, then we can add it in. Otherwise, we will add in inventory item of 0. So that should fix that stuff. Whoops, what'd I do now? I broke more things. So we have if the item, for the item in there, we're adding 1. We're off by 1. We start at 1. All right, cool. So solution is, I'm not crazy about some parts of the solution, but I think overall it does what we need to. So now I'm curious, let's try and submit it to the site and see what they say. So there's instructions here about how to submit, I think. Or no, it's somewhere in the exercism command. So exercism submit, yeah. And then we submit the actual file that we care about, which is the dix.py file. And we can open this URL. So we have a passing test. Here's our iteration. Everything passed, so we're good to submit when we're ready. That's just the code we did, so we don't need to look at that. And then let's check out a couple of community solutions and see how they came out. So I want to check out Zeppums and C-Kushes and Rakeshkers. That should be enough. Although there's some, wow, there's a lot of answers for these. That's interesting. Many of them did not have this many. So, all right. But this may be enough for now. We don't need to dig into dozens of these. So create an inventory. Okay, they inverted this. This is probably what it should have done, is created like it's actually the opposite pattern, where instead of adding a keyword argument here, they're saying like, let's start with an inventory, then call the add items thing. This is better. I should have done this way. So learn something. I guess I sequenced it wrong and was remembering a previous like solution, what somebody did for a creative way to do that. Okay, I like this. Some of the things they're doing here. So here's another method that you can call on a dictionary. And when you call get with the key, so this is like it's like a bracket access, but it gives you the chance to provide a default value if it's not there. So whereas I did the actual check using an if statement, they bypassed that by saying, you know, just if it's not there, just consider it to be 0, which is smart. And then they added 1. So that's a good solid way to do that. Well done. Their decrement solution, let's see, how's it compare to ours? Again, I did a look before you leap. So I feel like this might actually be missing one of the conditions, because this could be, the decrement could have an item that's not in the inventory. So I think that would fail here. And maybe they got lucky that the tests didn't check for that. That's why we had this item to remove in the inventory. So I'm curious, like the exercise did say do that, right? So the function should remove 1 from the available count in the inventory. The item count in the inventory should not be below 0. All right, so I guess there's nothing that explicitly says that it might be missing. So I guess the code that I wrote was a little bit more secure for the long term, like if you were actually to use this in a real context. But if you're confident that the inventory has the item, then yes, this is a good way to do it. I think they have the same solution that we did for removing an item. Maybe exactly the same? Yeah, exactly the same. Although they used I instead of, no, this one's identical. And then list. So their solution for this is the same, although they stuffed it into a local variable before returning it. That's interesting. The other thing that they did is this is, I wouldn't have done this. So they missed the fact that, look, this value, that is the count. So when they're doing this inventory on K thing, they're ignoring the fact that the value is also accessible there. So this is an unnecessary access on that, which is not ideal. It works, but it's not the ideal way to go. And just as a semantic thing, or no, not semantic, a style thing, it would be, I think, preferable to use meaningful names. In this context, we know this is an inventory, so we know it's an item and a count. In fact, I bet if they saw the fact that it was called count, that might have been like light bulb moment of, hey, I can just use the count here, which is why they might have missed it. Well, I don't know if it's why they missed it. I think it is a likely culprit of why they missed it. All right, so good job on that person's solution overall, though. Take a look at another one. Create an inventory of items. So they're doing, oh, I like that. This is, see, I knew there was some more clever way to do this. So they're using the count method on the list to count the items. Although they're going over this multiple times, so this actually might be inefficient in some ways. Because it's going to set the key and the value. So if you have, let's say you had wood in the list 3 times. So you had like wood, coal, wood, wood. So it's going to say wood. The first iteration is going to say wood. What's the count? The count is 3. So it would set a key and the value. And then it would do coal. What's the count? It's going to be 1. So coal is the key. The count is the value. That's good. But then it's going to do wood again and to redo that computation here to look for the count again. So, and it's going to set the key and overwrite the value again. So that's wasted. And then on the 3rd time, it's going to do it again. And what I'm afraid of is that this count operation, like that works on a really small list, but this count operation probably scans through the whole list every time. So on a gigantic list, I think this would actually be an inefficient method to do it that has a bunch of wasted computation in there. So that's, while short and sweet, maybe inefficient. Their add items they kind of called, oh, that's interesting, they called create items. They give it a weird name. They call it items again, rather than the inventory. I don't know, this one looks bizarre. There's a lot going on here, which I don't think is very comprehensible. Like there's a bunch of combining. Yeah, that's a strange way to do it to me. Yeah, Derek, so I don't know if you're joining a little bit later. I did use a default dict at first, and I used a default dict in here in the create function, and then I tried to call it in my add items, but I violated by the inventory that was passed in wasn't guaranteed to be a default dict. So it kind of violated some stuff. But yeah, generally though, I agree with you. Using default dict is a good way to go. All right, let's continue scanning on though. So decrement, yeah, there's some, I don't know, this solution's just not gelling with me. It's like there's a lot of stuff going, like the fact that I have to scroll for this line is maybe a sign that it's just too long. So I don't even want to take the time to comprehend it. It's just too much. Okay. Oh, this is another good way. I do like the remove item solution. So I did a delete, and I checked first if the thing was in the list, and then I called a delete on it, which is like the safe, a safe operation for what is potentially going to throw a key error. And this is another clever way to do this. This is pop. And the way pop works is it does kind of the delete operation on the inventory for that thing. But if the thing is not in there, again, it would throw a key error, but it gives you a second argument. So what happens if it's not in there? And in this case, it would return none. So good job on them for using pop as clever usage there. And then why? Why would they call so items? Okay, so this whole thing is a pair at that point. And then they're looking, it's a tuple. It's really poorly named, I would say. This isn't it's not an item. It's a tuple that's a combination of the item key and the count. And then So it gets that across. So like it's right, and maybe efficient. I don't know. But again, it's a hard to comprehend this, especially with that short name. So there's some cool stuff in here. The pop was a good thing if you're not familiar with that. But some of these are just like, no thanks. All right, let's look at one more and then we'll move on. So create inventory. They did it the right way, I think. Again, the way I should have done it is starting by using add items and then calling items. That's a good way to go about it. They do the default access. Again, this is a good solution. I think this is better than the way I did it for sure. Okay, I knew somebody was going to try this with a max. So if you remember, one of the constraints on the problem was if it's you can't go below 0. So that was this decrement thing. So it's trying to say, here's a scenario where you could fetch this, and it could already be 0. And if you subtract 1, it's going to move to -1. And then they're calling max on it to say, well, if I've ever gone below 0, just give me back 0. This is a way to do clipping, is what it's sometimes called, I think, in like game development. And it's a very good way to constrain, like so that you can't go above. Conversely, you can do something with min, and like if you have, I can't go any higher than a value, you use min to constrain in the other direction. So good clever trick there. Okay, so they did the guard, and then they did a pop. I think the pop is a little wasteful here, because the pop is saying, like, I want to return a value into a variable. So I think it's semantically more meaningful to use a del instead of a pop, especially if you're going to do this. The other person's solution where they used pop with a default was a good thing, but I think pop feels out of place if they're doing it with the guard check here. And then finally, like, why did everybody do this? They all did key value. Like this is the name of this was item and key, or I guess maybe they're following the doc string, which again is probably the fault of the doc string, because everywhere else we were talking about this as items and counts. So that's strange to me. Okay, cool. They all did all the solutions are pretty good. Some of them have maybe better parts than others, but they all had something to teach us, which is neat. So let's finish this up and go back to our solution, and we will submit it. I think we have to do that over in the overview page. And we're going to mark it as complete and share it. So if somebody wants to learn from the way I did it, that's cool. So we've unlocked more stuff, which we will not do today. We'll go back to the concepts page, and next time we can visit this. And I think we're down to the last 3 things on here, which is cool. And then there's like tons of other exercises that we can do. But that's where we'll stop with the Python part, and then we'll move on to something else with the stream. All right. It's been a while, honestly. So I've been taking off a fair amount of time. We were redoing the basement in our house, which is where I am right now in streaming. So I have not touched my projects in a meaningful way in quite a while, which means that there's stuff that's built up and that I'm working through, and we can just take a look at the issues list. There are a couple of easy things or easier things that happened, and I think I'm trying to decide what I want to cover tonight. So I could spend a bunch of time on Django, but I also have some other interests that might be fun, a fun divergent way to go. And I know this stream is marked with Python and Django, but I'm not above working with some other language. But first we'll do this one, which is a good easy fix that we can cover, and then we'll move on to another project. So what I found, well, not what I found, one of my users found, is that my website, my homeschool app that I work on, does not have a good 404 page. It has a generic white page when they hit a problem. And that was embarrassing, but should be easy to correct. We can add this to Django, and refer to it and actually show a good 404 page. It's not hard to do. I'm going to have to refer to the Django docs because I don't remember the exact name of it, but Django HTTP 404 I think is something, it might be the setting name or something like that. Let's do this. Let's do custom 404 page. And there should be somewhere 404. Okay. So there's a way to do this to set it in our settings of what to do. And I think it might be as easy as providing a template, and that would be it. And then everything else will be handled by Django. So let's look at that. Let's go to the base file, or the settings file, sorry. And let's look for the 500 page. Oh man, no. 500. So you can see I already have a 500 template for errors that happen when there's a problem on the site. And I want to essentially use this. Yeah, John, HTTP 404. I don't know if is that like a setting name? Where is that? It's not referenced right here. So I thought it would be right here, but I'm not seeing it. So you can implement it, or you can do like a custom page. So I think that's what you're referring to, John. It's like somewhere you can like override this stuff, but we don't need to. Like I don't have complex needs here, but I want to be able to test it. That's what's the difference. Is like I have a somewhere on this in my test suite is a test of the 500 page. There it is, handle 500. Let's search for this. So I've got handle 500, and the only point of this was so that I actually like look at my 500 page. And there it is. Okay, so I do use this. Ah, that's why I'm confused, because I have it it goes in the URLs file and not in the settings file. That was what the confusing part was. So we're going to follow this pattern, I guess, that I did with the handle 500, but we'll do it for handle 400. So is it handler 404? Let's search. Because it was handler here, handler 500. Okay. URL dispatcher, handler, yeah, handler 404. So we will follow an identical pattern of saying, well, let's start with the test. And we're here. We want to do another test just like it, but we want to do 404 and call it 404. And we expect the status code to be a 404. Is that going to pass? Oh, shoot. Okay. So what's happening is this is returning a valid or an invalid. Really? Handler. It was right here, right? Oops. Handler 404. Yeah. So what's happening is like the test framework is producing a URL that doesn't exist and it's trying to go get it, and that is legitimately returning a 404, which is normally what you'd want on any other view in Django. But here is the case where we're specifically working on a view whose job it is to return a 404. So the error condition for most views is actually the success condition for this one, which is why it's strange. So this is actually technically a bad test. It doesn't actually assert anything. So maybe we should assert something in the body of the test. That I think would prove what we really need. So what should we do? Let's go to Let's go to the Office dashboard, and let's put another thing right here. We'll replace it with 404 and call it 404 and 404. Python writer, you're welcome. I'm not really sure what you're thanking me for. If you have more details there, I'm happy to dig into that. Okay, so we've now got some views here. The views are going to be coming from the core app, where we're going to put this thing. And let's go to handle 500. And I'm going to copy the whole thing, paste it here, and we'll call it 404. And say 404, 404. Oh my word, this is so boilerplate. It's okay. Okay, so we'll go back to this file, 404, and now, okay, we're good. We're getting an exception because the template doesn't exist. So this view, now I know that something is happening. It's trying to render, but it doesn't exist. So we need two things. We need the template. So let's go to the 500 template, and we will create our new file at 404 HTML. And back in here so it renders better. And we'll say, I think people are used to seeing that kind of, are they? I don't need to give my users a status code. Let's just say not found. And then we can say, sorry, we can't find what your, hold on. Nope, that's good. We can't find what you're looking for. And then here's a case where 404 is going to be a good thing for like a permissions check sometimes, but other times it's going to be like something went wrong with my site. Like that's the scenario where my customer hit. They hit this white page where it was a 404, and I found a bug. It was like something was wrong with my code. It was giving them a 404 when really it shouldn't have been. So I need to hint to them of like, if you think that shouldn't have done that, then contact me. If you think something is missing, I don't want to invite too much support requests, but please contact support and I will look into it. All right, it's better than nothing. Is missing that shouldn't be. A little verbose, but okay. Do I log for, so that's I do log, how do I answer that? Yes and no, John. So a 500 request definitely gets logged. That's what goes to Sentry. And so that would show up in the error tracker. In the case of this thing that my customer reported, it was a 404. And I don't normally treat 404s as like an error message that is bad, because like you could have bots that are like scanning your website and looking for WordPress admin plugins and stuff, and it's going to 404 like crazy, and which would just flood any kind of error tracker. So I don't typically view a 404 as a problem. It's like it indicates a client error, right? Like you think about what the 400 status codes means. It means like the client did something wrong in some case. So I don't log them, which is why I missed it. This is a scenario where I could have, and that would have been good, but I didn't. So we'll call it this, and we'll say not found. And that'll be that. I think what I want to do is also assert on some actual content here. So I want to assert response, the body or content. I never remember. Response content decode, because it's going to be in bytes, and so we need to be at like an actual text. You know, Ryan, good call, good point normally, but some of my branding in this case is like, this is literally something that I like. Let's go to the website for a second. I tell them, you go to the about page, I make no qualms about it. This is me. Like I'm a single guy running the site. I'm not a single guy, I'm married, but I am a single person who is running the site, and what they're dealing with is like a sole individual. So I wanted to like lean into the fact that it's a very personalized experience, and like that I'm the support guy and expect what you can out of that. But you're right. Like if this was a bigger company, so maybe I should actually, for consistency, I should say something like, "We can't find it, doesn't make sense." So sorry. What should I say? Sorry, the site. How do you say this in a generic way that is like not, there's no company, so it's not a we, it's the site can't find it, but the site, it sounds like very, sounds very distant. Yeah, it is the royal we, I guess. All right, forget it. I'll just leave it as we, and it'll be fine. So I recognize I'm kind of incongruent, perhaps, with my stance there. Ask GPT. I'll pass on that. I would like to play with that later, but not yet. I actually want to use some of that. I guess not ChatGPT, but some of the AI services and stuff for generating an image for my book cover for stuff. Okay, let's finish up here though. So I want to say not found needs to be in the response. That's what's important to me. Did I get it right? Ah, shoot. Oh, I did get it right. I just need to be in instead of, nope, other way around. Other way around, Matt, come on. So delete that. We want to do not found in response. Yeah, not for code, for English. Yeah, I don't want to wordsmith this too much. It's not that important. Like, I think I only have a handful of customers, and if I'm designing the page well, people are not hitting this page much. Okay, got a passing test. Now I'm more confident that it is my template because I'm there. Now, if I left it like this, though, I would actually be wrong because I've hooked it up on a place where I can test it. And I'm not even showing that. So one moment. Got this wired there. Did I put it in a... Sorry, y'all. I'm not talking very clearly for what I'm doing. Let's search for this. I thought I put it in a template. No, I just go to it directly. So right now, let's look at this. So we've got, we can start the makefile, and it starts Heroku, my local Heroku setup. And we can come over here to localhost on, and go to the office. Oh shoot, what is the username and password? Matt, no, this is not even the right spot. Oh, phooey. I think it's, yeah. Hey, cool. Not now. So over here, oops, wrong place. I have this office dashboard, and I thought I wired a way to like go to this directly, but maybe not. So you can test it out by going to this page. This is, yeah, do it right. That's certainly the case. I'm very much, since I'm the only person who is working on this project, I feel very motivated to do it right, because if I make mistakes, it's on my head later to clean it up. So I've got this Office dashboard space to like view my page, even so that I don't have to like generate a 500 error. That's why I've got it linked up that way. And thank you, appreciate that. So this is what the page will look like if something's not found. And I think that will be adequate. So let's come over back here and actually wire it into Django. So Django doesn't know about this yet though. So if we have a 400 error, we're still gonna get that white page. And that's because we haven't hooked it up to the handler thing. So to finish this off, we need to actually import the view and say handle 404 like that. And then down here, we need to wire these together. So we'll take this to be 404, and we want to do the same here. So now I've got a place where I can look at my 404 page if I ever needed to modify it, which is unlikely, but it's there. And I've got a test to prove that it does render properly, because I'm actually exercising the view in a context that is sensible to what would happen in the real situation. And I have now instructed Django to use the handler 404 thing, which we saw very briefly in the docs. If you look at the URL dispatcher docs, it tells you what you can do to like override for custom views. So I'm high confidence that this works. Let's run the test suite to make sure everything is going properly. And it's looking good. Omnicode. Am I self-taught or did I go to school? I went to school. Whoops, I missed something. Shoot. Crap. All right, we'll get to this in a second. I'll answer your question first. I went to the University of Virginia and did a computer engineering degree. I will say though, while I learned a lot of the classic like CS concepts there, like big O notation, some data structures. I was not a good computer science student. I was much better at electrical engineering. And it wasn't until I got into the actual software industry that I got much better at this stuff. Something is wrong, and I'm wondering if I didn't run the test beforehand. So I'm wondering, did my change break it? So there's probably an easy way to test. So let's comment out this thing, this custom handler, for a moment, and see how we do. And if a test suite continues to fail, then we know it's not the code that we just modified. I did make some various updates and the suite was running. Well, shoot. Okay. So we got something to figure out here. The handler 404 is triggering an error state. That's not cool. Oh, thanks very much. It's fun. So appreciate you joining in for a little while. So we got to look at our tests, see what's going on. We're in these, it's all in the same area. That's curious. Type error, handle 404 got an unexpected keyword argument exception. Did I just, well, maybe, let's, you know what I bet it is? Okay. The view might be passing in stuff that I don't anticipate. So we can look at handler 404 and handler 500. Handler 500 might have a different signature as 404. Oh, boo. No, neither of those are any good. Okay, they do say, okay, if you implement a custom view, all right, they tell me, all right, they did a good job. I just need to read. So the 500 says, if you implement a custom view, be sure it accepts a request argument and returns HTTP server response error, which I didn't do. I did a render and then called with a 500 status code, which is basically the same thing. But with this, it's saying it needs to have another argument in order to work properly. If you implement a custom view, be sure it accepts request and exception arguments and returns a 404 not found. All right, let's see what this code. Okay, so there's a second positional argument called exception, which we're not going to use, but I guess it's a necessary thing. So let's add exception. Oh, boo. I'm not sure what to do about this. I'm using a new setup here. I've got NeoVim going, and I've got, what's running? Pyrite. So Pyrite is the language server that supports Python, and it's the same thing that's ultimately powering VS Code. And one of the things it likes to complain about is unused variables, even if they're parameters in a function definition. We're not using exception here, so now it's complaining about this, and I don't know how to make it shut up. Basically, like, you can't just prefix it with an underscore to say I really don't care. I think you have to like mark it with a some kind of like code comment to say like don't pay attention to this, which is really annoying, frankly. I haven't bothered to figure out how to fix that yet. All right, let's look at the test now. Hopefully, and this is why having a good test suite helps out. I saved my bacon. That was going to cause a different problem. Handle 404. Missing one required positional argument. Oh man, this rabbit hole keeps getting deeper. Okay, type error. Missing? What? What is it doing? I'm wondering if so I could probably get around this in a few ways. I might be able to set this as a keyword argument. So it's got it as a positional argument, but as long as I have it in the second position, I could say equal to none, and it should be okay. If I do this, doesn't matter. I'm not using it either way. So let's try that. And I guess the testing library is like not happy with that. I don't feel super good about that choice, but I kind of don't care either. This is a pragmatic decision. So is it the problem is in the test client, or is it the problem like I really screwed up my code? That's what I'm trying to figure out. So here we got test plus comes in, and it does some stuff, and it does check exception, gets the response, wrapped callback args. Man, it's deep down in here. And oh, it could be my code, my library. Okay. It's probably a bug in my library. So I'm the author of Django Denied, which is a library that I extracted from this homeschool project. And I think my library has a bug. So I've got a decorator. If you were observant, you might have noticed it. I wouldn't fault you if you didn't. is I've got this allow decorator on the top. And to allow it, it probably is expecting something like star, quarg, like args and quargs, like this. And then maybe that would have let exception fly through. Okay. Again, I don't really care though. Like it's working enough. Everything seems to be hunky-dory. Let's declare victory and move on. The code coverage is 100%. So we should be able to commit all this stuff. And this is going to fix, what number is this? 808. I got the second monitor and my alt tab stuff's coming up over there rather than in front of me, which is kind of annoying. I don't know why. So we want to say add custom 404 page. And this fixes number 808. Right? 808. Whoa. Times 2. It's like it's meant to be. Weird. Oh, boo. You have divergent branches and need to reconcile them? What are you talking about? Git pull. You can also pass. Let's do a rebase on top. There. That work? I'm not sure what I just did there. And I've used Git for a long time, but there's still things that can pop up on you. It's like, what's going on? Okay, we've got our custom page. Did I mess up the sequence of commit history? Did I do a force push? I don't think so. All right, all seems good. I'm going to say that we're good there. All right, let's do something completely different. I need to learn a skill, and I'm going to be outside of my element, and we'll try and learn some stuff together. It's not going to be Python either. So if you're here for Python and only Python, I apologize. That's we're going to do mix it up, but we're not going to even do like REST or traditional Django. Pretty different. What I'm thinking of doing tonight. Here's the scenario. At work, I use Go, the Go programming language, and I need to get better experience with it. I've been doing some exercism in the Go track. I did this a few months ago, so actually, we've been working on the Python track, but you can see I've done a good chunk of exercises, so I've learned the core of the language. But something I tell people that as they're learning software is like, it's one thing to know the language. It's just like, that's obviously a really important piece. But learning the language's ecosystem is another important piece, and learning some of the tools that go along with that language, because there's a lot of cool stuff that people write out there, libraries and things. And I like Exercism a lot, but it's not good at teaching external libraries and stuff. It kind of covers some of the standard library elements, but that's about as much as you get. So I have a need to work with GraphQL at work. So I think, let me draw a note here. We're going to switch gears to Go and GraphQL. I need to do some experimentation with the GraphQL libraries that we're using to get a better handle on some aspects of it. And there's like some testing stuff, and there's some specifics of the library that I want to get my brain wrapped around. So I want to try it. And I've also not like started a Go project from scratch. Like in these scenarios that you get on Exercism, everything's kind of like pre-built for you. So there's a lot here that I'm going to be going over. And it may go well, it may go super poorly. I don't know. But we'll start a project here. And we'll call it, I don't know. This is like from scratch, Go GraphQL. Creative, I know. So empty directory. And then we'll talk through like elements of GraphQL along this process. I'm really hoping that I can get something up and running pretty quickly. And we'll talk through like the pattern that I've seen at my company and the benefits and trade-offs of that. Because there are multiple ways to make GraphQL APIs. And the way that I'm about to show you is not the only way. It is a popular way, but not the only way. And so let's get into it. I think first, do I have Go? I do. Which version of Go do I have? Whoops. Go version. All right, so I've got, I think that's a pretty new version of Go. Go 1.19. Anybody know? Any Go devs out there? Go langers? Gophers? Yes? Let's go look at the tool that I need. Why is AdBlock Plus talking to me? The tool is called GQL or GraphQL Gen. The Go community is a big fan of their short names. So this one will follow suit. So we need to follow along with this. Let me talk through this first. So what is the approach of this library? And what is GraphQL? Like, do folks know? Do you know what GraphQL is? Yes, no? What is GraphQL? I should find a way to do polls on my stream. I don't know. Do you know? GraphQL is a way to do APIs. It is the graph query language, is what the QL part means. And it's a way, Go is currently 120. Okay, thanks, John. I think I'm update enough. 119.4 sounds far enough along. So GraphQL is a way to do APIs that's different from REST endpoints. It's different from RPC calls, or you might have dealt with. It is modeling a domain or your problem space as a graph. So something that has a hierarchy and a set of nodes within it, and a deeply nested structure if you want. And you can build up a graph model in that way. And it has some interesting attributes to it. And one of those interesting attributes is that you basically get to query at a client. So somebody who's like writing mobile app or a web application or something like that. Anybody that needs to consume this data and consume the graph and ask for the exact pieces of information they need. So if, let's say, you had a traditional REST API about books, so you might have, and the example in this website might even be books and stuff. I don't know, or that might have been in the Apollo docs. It doesn't matter. Let's say you had a traditional REST API, and it was about books. And so you had a books REST endpoint, and then you had an author's REST endpoint. And so in order to get information about your book and your author, you might need to do multiple queries. There's a possibility that one query might include all the information that you need, or it might just have an identifier to the other endpoint that you need. So let's say I'm looking for Lord of the Rings, and I get an author in the payload that is just an ID. And the ID is given to you so that if you want to go and get more information about the author, Tolkien in this case, you could then go do a second query and get that ID. And the reason for that is like the implementations are kept separate, the data models kept separate, and it gives you like, you only kind of ask for the resource that you care about, resource that you need. That's kind of the REST way to go about it. In the GraphQL model, it's more like, here's a book and author is a sub-element within the graph. And you can say within the author model, you might have the last name. And so you can ask for, I want this book, Lord of the Rings. That's what I'm going to filter on and query on. And give me back the publishing date of the book. And within that of the author, give me the author's last name. You get that all in one nice single query. And that's pretty powerful. And while it's great for the clients, there are some considerable challenges if you're the person implementing the API, which happens to be me in my case. But there are some interesting benefits that come out of it. One of the things that you can do that a larger company can take on, which is what my company does, is something called Apollo. Well, this is a product, but something called federation. So it's the idea that as you're making your domain model and your graph, from the client's perspective, you can show this as one big thing. Like, here's the whole domain, and give that complete point of view of everything is available. Just query for it, and it all magically comes back from the API. Single shop to go to. In some models, that could be a single service. Like if you're the way you implement your backend, you might have a simple enough domain that one service can handle the entire graph. But there's this concept of federation, which actually allows you to say, you know what, instead, I want to present an entire domain model as a single thing, but within it, I want to say this part of the model comes from this service over here, and that part of the model comes from this service over here. And so you kind of get this like mixed setup like that. And it allows you to split apart your backend into multiple pieces. This is what we do at my job. We use Apollo Federation. I'm not going to get into Apollo Federation tonight. It's more advanced, and I'm not going to be using multiple services, but I want to essentially explore the role of one of those players in that graph. So if you have a federated graph, any individual contributor is called a subgraph. That's not a really important detail, but that's just something that I think about. So GraphQL is pretty interesting. There come with it various problems with data management. So it's not without its fault, but it is still a useful tool that client developers tend to love, because it really does make their job easy. If I just want exactly this stuff, and they can go ask for that directly. Let's talk a little bit about gqlgen. There are a couple of different ways to produce a GraphQL API. All of a GraphQL API is based on a schema. So one of the other benefits of working with GraphQL is that you have type information for every different field you're trying to access. So a developer knows exactly whether the thing that they're trying to get is an integer, or it's a Boolean, or it's some more complicated object type, or any number of things. And because there is a schema, there are two modes of getting to that schema. You can either, as an implementer, you can write the schema first, and so you could essentially design your API, and then you use tools to read that schema and generate the code that would then integrate and produce that schema. We'll talk about that in a second. The other mode is an inverted code-first approach, where you write code that models what you want, and you produce a schema out of that. So if you're working in Django, for instance, there is a popular package called Graphene, and Django has an integration with it. And this approach is a code-first approach. So you write your models and your different things in Python, and then out as an output, you will get a schema to work with. And this is kind of like similar to Open API, so or Swagger, as you might know it. So Open API is a similar concept for REST. This is and so it's something that in the REST world, clients tend to like Open API as well, because you can actually generate code from a specification document from Open API. Either way, it's about getting very detailed typed information that can work as functionally as documentation, but also that tools can leverage to do some validation on. So there are, a reminder, there are like two approaches. There's the code first approach, which is what Django does with Graphene. And then there is the schema first approach, which that is what gqlgen does. And it even says right here, a schema first approach. You define your schema, and then you generate your, the tool will generate the code that you're going to then hook into. It kind of gives you stubs, and your job as a developer is to like fill in those stubs. Okay, hopefully all that makes sense. So here's my dilemma, and the thing that I want to learn more about. There are patterns that are in this library that, you know, there's all these things on the side that I've been exposed to with my with other services that I've seen at work, but I don't have a good handle. I've not internalized this yet. So I want to read some of this documentation, learn about some of these pieces, so that when I return and see, you know, selfishly, when I return to work, I will see some of these things played out. But I just want to, I just have a desire to learn this better. So I want to work with this and make a simple graph, kind of poke at it, like give you all some exposure to what a GraphQL API looks like. It'd be fun to play with a little and see how that goes. And then the other thing, my other objective out of this is I want to understand better how to do testing on this. Like what's a good way to test a GraphQL API? This is sort of an unknown to me. That's where I'm coming from. So we're going to start with our project, and I'm going to follow along with gqlgen here with their starting guide, and we'll see how far we get. I can't imagine that we would get crazy far in a half an hour or an hour, however we spend on this, but it'd be good exploration. And if you have any questions about Go along the way, I'm happy to try to answer them. So let's follow what they say. So we already learned GQL is a Go library. We're building GraphQL servers without any fuss. That's debatable, but we'll see. Prioritizes type safety. That's good. So that means, so Go is a typed language. So that's something different from Python. Well, people are going to argue with me on that. Python has types, but you do not see them immediately. You use the optional typing system to expose them if you want to visually see them. But Python doesn't require types. You can write a variable without a type definition on it. So when Go is saying it values type safety, it's saying we're not going to work with just plain interfaces. So a map is Go's version of a dictionary, and interface is a very generic way of saying, like, I don't know what this object is. It's pretty close to Python's any, as far as I can tell. So GQL enables code gen. So code gen stands for code generation. We generate the boring bits so you can focus on building your app quickly. Again, that is up for debate. May be true, but we have to prove it out. And then there's this comparison matrix with some other tools that we're not going to compare against, because I'm going to go with the choice that my company's already made, because that's what I need to learn. So we've got our a Go module, or a directory, I guess. We're in the directory, and we can do go mod init, and then I guess we repeat the name, go mod init example, or let's just call it, let's see what happens if we follow it directly. Go mod init example. I might create a package. What happened? All right, so we've got a single file. It's a Go project now. There's no, this is not under version control, so we're just kind of flying by the seat of our pants in that regard. Let's stop doing flying by the seat of our pants. Let's say go git init. Oh, boo. Git branch m main. Okay. And we've got a go mod file. Let's open up a second thing here and let's look at that file. See what's in that. Okay. So we've got our module as named example and it's telling us which Go version we're using. So far, so good. Let's start by adding that to the stage. And let's move on to the next thing. So it says add this thing to your project's tools.go file. What are they talking about? How can I track tool dependencies for a module? If you want to use a Go-based tool, stringer, I don't know what that is, while working on a module, and you want to ensure that everyone is using the same version of that tool while tracking the tool's version in your Go mod file. Okay, so let's break this down a little bit. The Go mod file, and I do know that's kind of like it's the direct dependencies that my Go code will depend upon. So it's keeping track of all of that stuff so that it can reliably download and rebuild the Go code from that module file. So it's kind of like, it's closely analogous to a requirements.txt file in Python. If your requirements.txt doesn't include all of your transitive dependencies. Or in my homeschool project, if you've seen other streams, it's like my requirements.in file. So the one currently recommended approach is to add a tools.go file to your module that includes import statements for the tools of interest, such as blah, 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 along with a go build tools build constraint. Okay, again, I don't know what this means. I think these are like special magic comments that Go can do stuff with when you build things, but I don't know for sure. The import statements allow the go command to precisely record the version information for your tools in your module's Go mod, while the go build tools build constraint prevents your normal builds from actually importing your tools. Okay, don't quite follow that completely. For a concrete example of how to do this, please see Go module by example walkthrough. Discussion of the approach is they've got comments in GitHub. And the rationale. I think the tools Go file is in fact the best practice for tool dependencies, certainly for Go 1.11. All right, so this is a practice that's been around for a while. I like it because it does not introduce new mechanisms. It simply reuses existing ones. Huh. What are they doing? So they've got this. They create a tools file. I don't know what this means. Package tools, blah, blah, blah. Okay. See if we can just follow GQL. Yeah. Add. We're going to copy. Interesting. Let's copy this and try it out. All looks safe to me. Should just create a file. Now we have a tools file here as well. So that's got our, whatever these little directive things are, I'm not really sure. And we've got a couple of things that are here that it says it could not import them. It means I don't have them locally with my Go setup. Okay. So now this go mod tidy command is like, what that does is to, actually it might even have docs on it. Go mod tidy -h. Oh, come on. Go help mod tidy. So, like I said, Go module wants to keep track of like what you're actually referencing in your code, and so that it can be rebuilt in the future. So Go mod tidy like scans through the code and populates that Go mod file with stuff, which we're now in a position to do now that we have this tool file. So if we write Go mod tidy, I think what's going to happen is the gqlgen stuff is going to be added to the Go mod file. Now here's what I don't like or understand about Go. I don't know where all of these library things went. Like, they're not here. There's nothing here. Like, I have a get directory, I have go mod, go sum, and tools.go. I'll explain go sum in a second. So it downloaded some stuff, but I don't know where, and that kind of bugs me. So we've got homebrew go. Like, did it put it in my home directory? I don't know. Is there a .go in home? Etsy or opt? Is that true? I mean, I believe you. I don't have any reason to not believe you. There's a Go directory in home. What's in here? I don't think I created that. Go package. This is seeming like it might be. Okay. I'm starting to think that this is maybe where it's storing this stuff. Let's go in here and actually tree go package mod. Let's go one more. Okay, so it's actually downloading all of this Go code in there. Fascinating. And just storing it all. So it's not, you're not passing around binaries or anything. It's literally just Go things that it can reference. So there must be some like Go build path or something like that, that when we're doing a build of the Go stuff, it will go reference this location. And it's going to do it in confidence because it has this Go mod file. So here are the new lines that got added, and we can see this is looking a little differently because I added that file earlier to the stage, and you can see this is the one that we're actually directly requiring. That's because of that tools.go file. And then here's all of the indirect stuff that came along with it. And looking at these, most of them seem like they were in that Go directory in the top. All right, cool. I'm down with that. Now, there's also another one that has go sum. And these are checksums that get recorded as well. So you can validate that that the stuff that gets into that Go directory is what you expect it to be. So that's like if you really want to be very precise about what is getting built. What is it go build? So what happens if I do go build? Build constraints exclude all Go files. What? What is that? What? Go help build. I thought it'd be go build. Generate Go files. Run. Test. So here's go build's help. Build compiles the packages named by the import paths along with their dependencies, but does not install the results. Yeah, I don't want to install anything. All right, we'll keep going. We've got go mod tidy, and then we need to initialize gqlgen config and generate some models. All right, let's do a little checkpoint here. So we're going to add all this stuff, and we'll commit it and say initial addition of gqlgen. I'm going to be sad if this takes too long to like actually get to something meaningful, and we're just go through the tool setup. I guess we shall find out how fast I can go. I don't want to go too fast. I want to like understand this. The whole point is to understand it. Maybe they've got a good starting point here. So we're going to run gql init, gen init. And I think this is going to work because we now have GQL, we've got gqlgen as a requirement. So I think we've already downloaded it by having in that tools file. I don't think it has to download anything else. So what is it making? We've got a YAML file, a GraphQL schema file, and a server file. All right. Let's take a look. So the schema file, that's what we're going to modify later. It's now in a graph directory. And they're going to, because this is a code generated approach, it's going to store the generated file somewhere else. We're not going to do federation, so we're going to leave this alone. There's a model file. Don't know a lot about that yet. Where should the resolver implementations go? They're going to go into a directory, the graph directory with a graph package. And I don't know what this layout follow schema thing means. All right, so there's a bunch of stuff in here. And then we've got, what is this section? Models. Section declares type mapping between GraphQL and the Go type system. Okay. So there's got to be some like translation, and this tool is giving us types. Anytime we're like, there's an ID type in GraphQL, and there's an int type in GraphQL, they can map to one of these model types in Go. Okay, cool. That's that file. Let's look now at the server file. So there's some stuff here that like, I don't know why it's not referencing that, but maybe my LSP needs to be restarted. Okay, yeah, that was it. So it didn't, my LSP server didn't seem to know. I'm getting a message down below there for Go, please. Package, I can barely see that. Good grief, that's tiny. Package load error. Updates to Go mod needed. Disabled by mod read only. To update it, Go mod tidy. Do I have to run Go mod tidy again? I don't know. Let's try that in a minute. Before we do that though, let's look at this. We're already looking at the server file. So there's a server that's created. It will look for a port, and then it's going to create this schema, essentially. So it's going to create a server using this handler thing. It's going to build an executable schema, so that's the thing it can run. So it's probably wiring together all of the functions that were generated. It's going to use a configuration. I don't know much about this resolver stuff yet. And then it's going to put everything. So here's the server object, and our GraphQL API is going to be at query. I don't know. Query or slash. I don't understand why there's two of these. Playground handler, blah blah blah. Maybe it's like a redirect. I have no idea. Okay, so that looks like a define start. Now we've got two dependencies in the Go mod. Let's add those. Let's do, before we do anything else, and there's a bunch of generated files. I guess we didn't look at those. There's this thing. I don't want to spend like, it's generated code, so they're doing stuff. We have this resolver, which I think we're going to learn more about later. And then here's our, okay, they come with a schema. So here's a GraphQL schema. It's not syntax highlighting. Why is it not syntax highlighting? I might have only done that at work. Oh shoot. Boo. Do I want to fix that here? I think I do. Let's do split. And I'm now in my vimrc. So I'm missing GraphQL syntax highlighting. So there's some place. Oh, maybe I have that in my. Do I have a branch I've pushed up? I think I do. So there's some changes I have to work with at work, and this is where I put them. And I bet the GraphQL stuff's in here somewhere. Yeah, there it is. Ensure installed GraphQL. Is that it? Buffers, last use. Yeah, okay. Ensure installed. Put it in the same spot so I don't get a conflict. GraphQL, just like that. Now let's try quitting. Open up nvim again. And it's going to go get GraphQL. And now we should be able to go to that schema file and it should look way better. Any luck? All right, cool. Syntax highlighting for the win. So here's our GraphQL schema, and it has a few objects types declared in here: a to-do, a user, a query, so on. And then we have the ability to create a new to-do. Okay, cool. So let's do this. Let's say, what is this after? What step? After gqlgen config generation. So the way this works, I think, is there should be a bunch of things in here somewhere. Yeah. So here's an example of what happens. So we saw that schema, right? The schema was showing all of these things. And when you work with GraphQL, there's like two primary ways to interface with it. You're either trying to do a query, or you're trying to do a mutation. You're trying to change something, mutate it. And so you define one of these, you define your actions or queries in either a type query, and then you give like a whole, this is where your graph, your tree goes. You'd say like user, stuff like that. I'm not going to go into the, oh, there it is right there. Here's the query. So they already have it. So let's just talk to it here. So a query, and say I can now query for all of the to-dos in this demo thing, which is a mandatory list. That's what the exclamation point means. It's like it's required. So it must be a list, and if there are items in the list, they must be a to-do. So you can't have null in either. You're either going to get an empty list, or you're going to get a list that has to-do items in it. And a to-do can be one of these things. So when you query, you can query for a to-do, and then you can query for user attributes within that. So we've got all of that, and then we've also got the ability to mutate, to create a to-do. And all of that stuff, all this schema, has been generated into resolvers. So the way this works in GraphQL is each one of the things in the schema is considered a field. So text, well, better example, like ID, name, those are fields in this particular type. And fields will be associated with resolvers. So like a resolver maps to a field. And it's the job of a developer to actually implement the resolvers, which is why you can see here, I guess in this case, the actual field is this to-dos thing. That's the field in the graph. So we've got a couple of resolvers that came out of our code generation, and they're currently, their implementation is to panic. And panic is Go's way of saying, like, I don't know what to do, I'm giving up, and I'm going to crash the whole program because I'm not implemented, which is not good. You don't want to leave panics in, obviously. It's just really, it's like a reminder to you of like, hey man, you're not done. This isn't magic. We do have to do something. So this is where we would start putting our code. Now, a resolver, I think, like in a well-designed app, should not be doing a lot of work. You should be handing off to some other package. So it's really meant to be like the receiver for some request. Maybe it does a little bit of validation, and that's like acceptable and normal, but the actual like work of creating a to-do should be sent to some other kind of function to actually do that work. You want your resolvers to probably be pretty lightweight and thin. Okay. So let's try this. Go run server. See how it goes. Oh, huh, interesting. Typed parameters requires go 1.8. Well, what did I thought I had go 1.19. What? That's not cool. Type parameter requires go 1.18 or later. Lang was set to 1.16. Check go mod. Liars. Go mod 1.19. Not a good start when we got through. So we got through the creation steps, fine. And then I would expect go mod run server to go. Weird. Okay, let's see if we can search for this and if it's going to give us something. Hello? John, I'm curious what you mean by update to current. Go. Because as far as I know, yeah, I don't know. If you have, oh, I see what you're saying. But like I hear you. I'm wondering though, shouldn't I be okay? Like, as far as I know, 19 is greater than 16. So why, like, I don't know that type parameter requires go 1.18 or later. So what's going on? Maybe it's in the simple LRU has a go module of its own. That could be. Let's check that out. So must be, okay, so let's check out, we said there was stuff in the Go directory, right? So we could look at tilde go, and package, mod, GitHub, HashiCorp, Golang, LRU. Okay, there we go. So let's do the Go mod on this. But I think this is going to be the one that's going to say Go 118. Go 118. All right, so that's not surprising. That makes sense with the error. I wonder if there's, okay. I don't know what this lang parameter is. env, oh, this could be dangerous. I don't think I have any secrets that are in there. So since I don't know what's in my environment, I'm going to set this to this for just a second. Hopefully y'all can still hear me just fine. I'm going to look at my environment and look for Go related stuff. So I'm doing env pipe sort, and I'm looking for anything that has Go in it. I don't think I have any real secrets in here, but I just in case, I didn't want to like put that out there. All right, so nothing in there. So let's turn this back on. Okay. Well, that's freaking annoying. And look, like my command line, yeah, what is this tool called again? I have a tool that, shoot, what is that? The Starship. So Starship is the tool that's giving me all of my status line here. And the little hamster is supposed to be a gopher. This little cute oddity. And it's recognizing that this is 119.4. Go 119.4. Man, that is really annoying. Like, how am I supposed to go run server? Go build? Updates to Go mod needed. Okay. Go mod tidy. Yeah, that's a good question, John. I think the answer is no, and I think that the reason for that is because Go compiles everything. So it would be more necessary if it would be more necessary to have like a virtual environment concept if there was like a code that was running. So that Go directory that I have, the fact that it's just a source code area is probably okay, unless I go modify it. I think you could probably, I suspect what it has in its structure, and you can kind of see it here with this this package naming, is like the versions are built in. So every version you ever install of this Golang LRU is going to be downloaded in there. That's a little, it's kind of similar to NPM in that way. And I think that system works because Go is a language that gets compiled, so it really doesn't matter whether you have a virtual environment locally or not. Like, there's not going to be a conflict, I think. So let's do what it says here, run go mod tidy. And it's adding more indirect stuff. I don't know why. So this is the part that's like mystifying to me. Maybe that'll correct our error. I don't know. Because look at it. It's clearly touching Golang LRU here. So what if we run go server go now? All right, well, okay. I don't fully understand what that did or why it detected that and didn't do it before. Sometimes I don't understand the sequence of this stuff, but it's okay. So let's go look at, let's look over here. Go to 8080. Let's go to localhost. I think it's going to come with a playground feature. Yeah, cool. So this is graphical. And you can see what it says. GraphQL is an in-browser tool for writing, validating, and testing GraphQL queries. So we would write pretty5 merge copy. Is it going to help us write our query? We say, oh, good. It's got some like autocomplete stuff. So we should be able to say query, and then here, this is how you structure a GraphQL query. Run query, control, enter. So we know from our schema file, which I think should be in here. Bella, welcome. We're doing something different tonight. So we're not doing Python. I did some Python earlier, but we're doing some Golang right now. So I'm messing around with a tool. I mean, you're not too late, I suppose, but I don't know how much longer we'll be going, but we'll see. Okay, awesome. So GraphQL's got this, and we're messing with GraphQL. That's what we're doing. GraphQL, that's this tool, GraphQL, GraphQL, I think is how they pronounce it, comes with the documentation. So what I was saying earlier is because GraphQL has a schema that is well typed, you can actually use that information and like get on the fly documentation. So we can go look at this and we can say, oh, what's in the query? Oh, it's got a thing of to-dos. So and an editor tool like this can like say, oh, you want to make a query and you want a query for to-dos. Now, the to-dos is a list, and so you can't just query for the to-dos. It's telling you must actually say what fields you want. So, oh, you're creating a microservice in Golang? That's cool. So you have to ask for some fields, and so that we need to know like what's going to go in our fields. So we have we're going to get some to-dos back, and let's say we want the text. Now, with everything here, that should be a valid query, but we did not implement the resolver, right? So we've got, where was it? The resolver over here, and it's going to come into this to-dos. To-dos is the resolver for the to-dos field. That's what this is telling us. So we're gonna, when we run this query just in a moment, it's going to come in here and hit the panic, and it's gonna say not implemented. That's what should happen. Hit the button. All right, so yeah, that's exactly what you'd expect to see. To-dos comes back as null, which is kind of ironic actually, because it said that in the schema, we go back, it said to-dos should not be null. It should be like an empty list. That seems weird, but maybe all bets are off once you actually get an errors thing that goes along with it. Yeah, we are using a Golang framework of sorts. I guess I don't, well, maybe answer, I'll tell you what we're using, and then you can tell me if this is a framework to you. We're using this tool called gqlgen to do a schema first approach where we've got the schema and we're doing some code generation, and then we'd be writing our resolvers from there. So we're at this step right here where we are running the server that it generated from this project. So this is the quick start. Then we've got frequently asked questions. Do I need to get into any of this stuff? I don't know. Hopefully not. Or at least not yet. So let's take a look. Okay, that's a framework to you. I didn't know if you meant like something more full stack, because I talk about Django a lot on here, right? So I don't know if you meant something that does like a lot of different things at once. Okay, let's look at a little bit more and see if it can tell us. Ah, cool. We've got some information here, because one of my coworkers likes to point out that we shouldn't be checking generated code into source control. It makes for hard code reviews. There's a lot of code. that has, no author made it, is made by a tool. So why shouldn't we view that as like a code output and just generate that at build time? And this coworker, I think, is probably right in that statement. It's like it makes it hard to see what is the code that we wrote versus what is the code that the tool wrote. So I don't really, I think in this sample app that we're doing, it's okay that we have committed all this stuff to source control. So that's fine for now. But if I was doing this in a different way, every time we generate this generated Go file is going to be, it's going to likely get modified. And it's just going to be line noise. And that's look, that's 4,000 lines of code that, why commit that to source control when you should not have to review it necessarily? If you trust that the generator is a consistent version, you should be able to trust that the generated output is going to be consistent because it's going to be going through the same code path each time. So there's an argument to be said that the generated code should somehow be ignored, but I don't know a way to tease that apart. How do you tease apart the generation and then have the right stubs in place, the things you do want to fill out? That's the bit that's unknown to me. Okay, but let's look at the getting started guide and see if it has explanation of what actually comes in with their setup here. And it sounds like they do. So we create a tools go and add gqlgen as a tool dependency. Talks about that. We saw that earlier. And then we run our go mod tidy and we get this such and such stuff. By default, you'll be using the latest version of gqlgen, but you may want to specify a particular version that you can use with go get. So what did we say in our tools file? Tools. Oh, I see. Okay. So you can go get at a version. All right. So then we create this command, and I'm not crazy about this. The way this is done is you have to specify, I guess, is this the package? The github.com/99design/gqlgen init. I don't know. It'd be cooler, I think, if go run would let you register or something as a, gqlgen could be a namespace in and of itself. So go run gqlgen init. That's a minor thing because I'm not going to remember that 99 Designs did this. I will eventually, but not for a long while. This might be information that you might encode into a makefile. So let's look at what's in here. A package that only contains the generated runtime. What runtime? Are they authoring a server? That's the other part about generated code. It's I feel like I know less, but although you could levy the same complaint out of a framework like Django, and in that case, the code's not even there. So maybe there's an argument to be said that generated code's actually a little better in that way because you could at least inspect it. So what is it doing? A lot of stuff. It's generating this executable schema. There's a bunch of bits in here. Oh, I don't even know. This is not worth investigating, I think. I'm sure there's probably some interesting lessons in there. A package for all your graph models, generated or otherwise. This is where, again, this line between the world of generated stuff versus the world of my stuff is fuzzy to me. Okay. Resolver is the root graph resolver. This file won't get regenerated. Okay. That's curious. This file will not be regenerated automatically. Ah, All right, so it serves as dependency injection for your app. Add any dependencies you require here. Okay. So I want to see some examples. Maybe they've got examples of that. I think there were actually. Let's go real world examples. What's in here? Examples, blah, 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 blah. Star Wars. That sounds fun. What's in their resolvers? What are they putting in this thing? So resolver is just an empty struct right now. And they're filling it with human. That's just a map. Oh, that's interesting. Okay. Droid. What is going on? Did they make... Okay, there's some generated resolver. Then there's droid resolver. Where's that coming from? It's coming from this file just later on. So 62. It's another type. Huh. Don't follow this well. So the resolver, okay. So here's something about Go. It's like you can add a function kind of to whatever you want. You use this like syntax to essentially attach a function. It has a name. I forget what it's called. But it's kind of like making a method. So this resolver is going to have a droid function on it. It will return a droid resolver. And the droid resolver function here is going to be the thing that actually provides that generated thing. Is that right? Am I reading that right? I don't think I'm reading that right. Okay. Well, I'm not going to get too deep in trying to understand this, but I guess the interesting takeaway is that you can use resolver as your place to add things. And that's where I'm confused about like testing for later. Do you mock out a resolver and build your own in a test and then call your own resolve functions that way? Don't really know. I think that might be the case, but I'm not positive. All right, so let's continue on. We've got, so there's probably some examples I could learn from there. Let's go back to the getting started thing. So we've got models. We've got this file that won't be regenerated. Here's our schema. If you split it into multiple schemas, I don't know necessarily why you'd want to do that. Because you're going to have to ultimately put stuff under query. I don't know. Maybe there's a reason for doing that. So the resolver implementation, that was the thing that had the panic, I believe. So we've got our, yeah, this is where the functions are that have their panic. And you can see they get an instance of a mutation resolver or a query resolver. Now, one thing I absolutely can't stand about Go is this like love for creating super short variables like this. Like, why was it called R instead of, what was wrong with calling it resolver? That would be too nice in the actual implementation. I don't know. That's my gripe with this language. An obsession with those short variable names. Okay, and then we've got an entry point for the app, which we would hang off like whatever kind of extra structure we need. All right, that's cool. So schema first, they gave us a schema. All right, let's take something out of the schema, see what happens. Let's try. Let's take out user, just for now. And we have to regenerate. There's a go generate. Oh no. No. How do I there's like a generate command, I think, that I think you have to do. I think it's like all of this again. This is like how you get to the command. Kind of like npm run. Let's take that. And let's say help. Okay. So we ran the init command initially. So generate a GraphQL server. So we took off the user for now. Let's say generate again. So what did that do? It cleared up. It modified our graph generative file and the models generative file. I guess we didn't look at the models generative file yet. Okay, so just took the stuff out of there. Do not edit. Well, what can we edit in the models then? Where do we put regular models? So maybe it's in the YAML file. Let's see what's in here. Model. Where should any generated models go? Okay, that's fine. Maybe we can put our own models separately as long as we give it the model package. I'm not sure where we'd want to do that. I guess if you have model concepts that are not related to your graph directly, which is reasonable. You don't necessarily want your graph to like match your system domain modeling. But the weird part is like that model directory is put in the graph directory. I don't know what other kind of model would go into this graph that's not going to be part of your graph. That part doesn't ring true for me. Okay. So no, it also looks like, no, these were staged before that. So we can just get rid of all that stuff and be back to having the user again. Okay. We define the schema. Neat. All right, here we go. Maybe there's more guidance here. So we implement resolvers. When executed, the generate command compares the schema with the models. And wherever it can, it will bind directly to the model. That was done already for init. Okay. Then we'll edit the schema later in the tutorial. All right, so they're going to do what I was doing, poking around with. But if we take a look at the resolver, we can see, we will see all the times that gqlgen couldn't match them up. So there are things that gqlgen can't resolve automatically. And for those, it gives us, that's the place where we need to implement things. That's interesting. Get those two methods working. And they're going to give us some examples. First, we need somewhere to track our state. Okay, I agree. Then we've got our resolvers Go file. This is where we can put our apps dependencies like our database. It gets initialized once in server.go when we create the graph. So this might be where you would have various patterns. So if you have like maybe you call it a service pattern, or maybe you have a repository. This is feeling like, this is very raw of, we're just going to give you all the to-dos as a list of pointers, and you can do with that what you want. That seems not greatest not so great long term. So this might be where you want to like be more thoughtful about what types you put in there, or in how you get access to them. Because if the resolver is the thing at the top. All right, let's see if I need to connect the dots here. There's something else I'm missing. So we've got a resolver. Where are the references to this thing? Come on. Go mod tidy. Why do you keep making me run this? Go build. Sample. Don't need that. That's some kind of binary. LSP restart maybe. Okay. All right, there we go. Aha. So we have a resolver at the top for query and mutation. Okay, and then look, this is the key. Oh shoot. Hold on. What file was that? Let's go back to that. Yeah. Okay, I see it now. So the mutation resolver is wrapping the resolver. Kind of is a resolver as well, but it's specific to mutation. And so it's like create to do is only going to be called in context of that. But no matter what, in either case, I think the R that's here, this thing that is currently classified as a mutation resolver, is going to have the same access to dependencies as this thing, because it's wrapped up that way. Okay, that's pretty cool. So if we were to attach like what might we call it? A to-do repository, using like, I think Martin Fowler calls it the repository pattern. Martin Fowler repository pattern. It's a way to like abstract data access if you need objects. You can say like, get me one of these. Sorry, just realized I puffed on the microphone just because I'm not thinking. Well, I'm not going to go into all that, but there's like, the client is going to like ask for the repository for a particular item, and the inside of the repository is going to be abstracting away how it actually gets whatever that repository is the owner of. So we have a to-do repository. You might say like find, and then have, or a find by text, or find by user, or something like that. And it could return all the to-dos. So it's kind of like kind of like Django's manager class a little bit that actually does your query set stuff. This is where I'd be interested, like ways to connect GraphQL to like data layer. Like this library doesn't care anything about the data. That's kind of left as an exercise for us as developers. And based on what you want to do, what data storage technique you want to go with. So here, instead, they just model it as, all right, we're just going to punt on the whole problem. Here is your chunk of code that you can do. So let's do that. We're going to create a to-do, take all this code. Whoops. Let's undo all of that. We're not going to use that. And I think he said, I don't know who wrote this. So we need to make our resolver handle this probably so that we can somewhere in here. Yeah, it's just, you can see that it's just dealing with a list. And this resolver list lives for the entire duration of the server. So it's like an in-memory store for now. So definitely not the thing you'd want long term, but it's good enough for a demo. So let's follow suit and paste in this thing. Paste. Okay, resolve this thing. Okay. So we've got our resolver now does that. And go build server. Is that how we do this? No, that's not right. I guess just go run is all we need. Servers, maybe as a server binary will just run. Okay. So we can build it if we want, if we wanted a binary out of this. I don't need that though. So if we want to just run it directly, we would just do that. All right, so now we've got our resolver has our to-dos, and now we're going to see that example played out here, the create to-do thing. So we need all of this code. Oops. Like this. And we want to paste that here. Oops. So we want math big and crypto rand, I guess. So this should still work. And that's our mutation. Like we were working with the playground. And again, this is like it's putting all the logic in the resolver. This is meant to be mostly a demo. So it's showing you like you need to be able to return a to-do and some kind of error if there's a problem. That's the expected interface of this thing. And how you do that is really like up to you. So that's fine. And then to do the to-dos part, we just get all of the to-dos is what it's doing. It's being very liberal with this and just saying, yep, just give them all. Because it wants a list of to-do references. Okay. So now we can run the server again. And all right, cool. And that gives us a couple of queries to try. Let's try it. Go run server. Go back to the playground. And instead of doing a query, we'll do Oh, come on. Paste that in. We run this. Hey. So it made a to-do with a user, ID of 1, and we'll say to-do 2. Okay, so now we have 2 to-dos in there, and then we should be able to query all them. We'll come back over to graphical and do this. Now we've got a list of 2 to-dos. Cool. Now the problem is as soon as we stop the server, those to-dos go away. That's okay. This is like mostly exploration at this point. I'm done with the real world examples. We haven't done any testing for that. We're not going to get to any of that tonight, but this has still been an interesting exploration. Also interesting to me is like the data you can see out of here. So this is what GraphQL kind of returns out of this. So we notice here's the shape. So we named a query and we said find to-dos query. We wanted to do, like, we know the schema and we want out of the schema, we want all the to-dos because there's no way to filter. And we want the text field, the done field, and then within the users, we want the name of the user. And that's the shape, the data we got back. So we got back our list, and in the list is a set of objects that has the same kind of nested structure. It starts at the data key and does that all the way down. So clients are able to take advantage of the parity between the schema and the result and like use that to their advantage. There's a lot of tools that can be built upon this because of that symmetry. All right. Let's look at some more here. This is almost the bottom, and I think this is where we're going to finish tonight. I'm not going to have time to get into the testing, but I have improved my understanding, which is part of the goal. Hopefully you've learned something a little bit about GraphQL in the meantime, or at least how it works in Golang here with this framework. So this example is great, but the real world fetching most objects is expensive, right? I agree. We don't want to load the user on the to-do unless the user actually asked for it. So let's replace the generated to-do model with something slightly more realistic. Okay. First, let's enable auto-bind, allowing gqlgen to use your custom models if it can find them rather than generating them. We do this by uncommenting the auto-bind config line. Okay. We're going to go back to the schema file, or the YAML file. We have auto-bind. Auto-bind's already here. And we have graph model. So it's already looking, okay, here's that example of, I said, there's this model's gen, and this is the generated version. So they're saying GraphQL will search for any type names in the schema that the Go package will. So it's looking for anything in this package, which model does do that. So show me more. Tell me more. Oh, then we have to explicitly tell it? Okay. So we've enabled auto-bind, so it's going to look for stuff now if it can. And then we come down and we go look at the to-do. Add to-do fields resolver config. Oh, okay. So the to-do model has a user, and we're telling it to use, hold on, fields resolver config in gqlgen to generate resolver for the user field. Generate resolver. Huh. Okay. Let's take that, add it to our models section. It's talking about this field. And interestingly, like these have to be public, so that's why it's capital U. It wants it to match the name as it appears in the schema. Oops. So the schema has this as lowercase user. So saying resolver is true, and then we declare I don't understand how this is helping yet, but I'm still working through the example. So then we come in here and we do to do, and we paste in redeclared in this block. Yeah, that's probably because it's in the generated file. And then we run the go run generate thing again. Okay, so let's see what happens. See what happens when we do that. Hopefully, it will get rid of the to-do from our generated version and use our hand-rolled version. I still am not sure how this helps yet, but we'll see. Go run generate. So what did it do? Generated. Let's check out the diff on graph models gen. Took out the to do. All right, that's what we expect. And what do we have here? Now we look in schema resolvers. Oh, okay. So we've got another schema resolver. Yeah, okay. Turns a to-do resolver. I'm still not sure how this is helping. We moved it out of the generated code. Great. But how does that help the problem? But in the real world, fetching most objects is expensive. We don't want to load the user on the to-do unless the user actually asked for it. What, the initial implementation have something else? Maybe it did. That's creating. I don't follow. Now if we look in this, we see a new resolver. Let's implement it and fix create to do. Fix create to do. What are they fixing? What's different? Because in both, I don't know, man. I don't see it. Maybe. Oh, okay. Maybe I see it. So this is saying it's got a to-do with the user. And the new version has a user ID. Saying like fetch a new user, maybe? Still not positive how that would be used in a context that matters. I think I have to stare at this like one more time. We don't eagerly fetch the user. This example is great, but the real world fetching most objects is expensive. There's no fetch here. This is all fake. So what is it saying? It's like creating a user record instance based purely on input from the mutation. There's nothing magical there. But maybe they're saying like, if this was a real scenario, that it would be making a new user. I don't know. We don't want to load the user on the to-do unless the user actually asks for it. This is probably meant to be client. So let's replace the generated to-do model with something slightly more realistic. We enable autobind, allowing gqlgen to use your custom models if it can find them, rather than generating them. Okay. The first line in each type will be used as defaults for the resolver arguments and model gen. The others will be allowed when binding to fields. Okay. The only thing I see different about this is the inclusion of the user ID field. Probably the idea of like you can reference this and yeah, you could associate, like I'll have a foreign key storage. I don't really know. So then when they're creating a to-do, it's still creating a user though. I don't know. I'm just not tracking with the example. I'm just going to accept it for what it is, assume that they're telling me something that I should understand later, and move on with my life. So we could replace that. What else is missing now? I think I have a new missing thing because of this. Yeah, there's a new panic here that I introduced because of this change. If I wanted this to be working again, I would need this instead of rand. It's like not even correct. Rand int is now, what's going on? Their code example not good? Rand int takes a reader. Yeah, something's wonky with what they've done here. All right, forget it. I'm gonna leave that alone. Let's look at this final thing. At the top of our resolvers go between package and import, add the following line. Resolvers go between package and import. What does this do? This magic comment tells Go generate what command to run when we want to regenerate our code. To run Go generate recursively over your entire project, use this command, go generate //. Go generate //. Okay, I'm just gonna have to take some of this on faith. GD diffstat. Okay. Well, that was interesting to me. I don't know how many people are left if folks are still around, but I am finding this to be a fascinating package. There's more to learn. I want to figure out how to translate this better. The gap still for me that maybe I'll try and look into in a future stream, if we come back to this, is to how would I actually test this? Like, do you test the resolver, and then if so, do you write a, because, well, let me see if I can answer this. You probably do test the resolver function and call that, and then that is like maybe the subcutaneous part of the test. Like all of the other stuff, everything generated and everything that's like plugging this all together ultimately is calling resolvers. Like that's this thing's job. It's building that all up. And so it's putting that all together in a way that can be calling everything that matters. I think I can see hints of that here. So maybe the idea is you don't need to generate a client. You don't need to go to that level. You like go the layer below, and rather than like putting together a pure GraphQL query, you just assume that this tool knows how to call do the GraphQL process properly, and your job is really on the resolver part, and you implement some kind of test resolver that has a different set of whatever's in there. Sorry, that was not very clear. Whatever goes into this struct, like you build one of these. This example is not great because it's just a list, but if you had that repository pattern or something like that, you could put in your own test repositories that are mockable and under your control, don't need to talk to the database, whatever. And then you could test your resolvers from there and ensure that they're working. And then you'd have another test for actually testing your repositories to make sure that they're talking to a different layer, to the database. So yeah, that kind of convinces me. I don't know how you test something like authorization, authentication. That is kind of a mystery to me. Like, how would you prove that that layer is working if it's like a separate layer from the GraphQL stuff? But it's kind of out of scope. All right, I think I'm going to call it there for the evening. Hopefully, people learned something new with either Python or Go. This was more of an exploration for me this evening. So if I left many of you out high and dry, because this is not really in your wheelhouse and you don't really know the Go programming language, I'm sorry. But I had some need to do this, so this is why I did it. That's next time I will either return to some of this, although it'll be a whole week later at work, so I might have already solved, I have need to solve this quicker than that. So maybe I can come back with some of my findings of what went well. But I feel like I have a much better understanding of these pieces now and the key of like that resolver. There's still some mystery stuff around, like what were they talking about here? How does this actually help? The text description is not good enough for me here to understand this. But yeah, that's how that is going to be for this evening. Thank you all for joining in, and I will post this to YouTube as usual. So if you want to refer back to anything, you can. If you're interested in gqlgen and playing with that, here I might I'll drop this into the chat. So there's a link for you. It's been fun, and I will see you next time. Take care.